Hello everyone, this is Ayush and from today we'll be starting third unit of class 10, that is current activity. Okay, this is quite easy unit, okay, cover, and it is also a very marked way. You can score easily score in this topic. Okay, this will be a basically a introductory video about this. Okay, so just think about this term current, electric current. The first term that will be coming in this unit is electric current. Okay, so we'll define this. It is basically a rate of flow of charge. Okay? Rate of flow of charge is defined as electric current. Okay, now this can be written as I is equals to rate of flow of charge. Means suppose uh, a charge dq is flowing through any area, okay, in time dt, then electric current that will be passing through that area or through that region, that will be I is equals to dq by dt, and this is also known as instantaneous current. Instantaneous current. And your electric current is this q upon rate of flow of charge, okay, or you can say the ratio of charge to the time, and I is equals to delta q upon delta t. This is defined as average current. These are the basic terminologies that we'll be using. Okay. From here you can also derive one thing. See, if you transpose this side, it will be dq is equals to I dt, and if you integrate this, it will be q is equals to I dt. Okay, this is a very also important result as well. So we'll be doing the problem using this result. Okay, write one question. Okay, the question is the current flowing through a wire is given as flowing through wire is given as I is equals to 2 plus 3t. Okay, now you need to find the charge crossed through a cross section of wire in first 10 seconds. Okay, find charge flown in first 10 seconds. Okay. This current is varying with time. In the capacitor we have studied about this type of current. This is what transient current. Okay, uh, you need to find charge, so apply this. Okay, this result q is equals to I dt. Here I is a function of time, right? So from here you can get q is equals to I is given as 3 plus 2t dt, and you need to find the charge in first flown in first 10 seconds. Means the time will be from 0 to 10. Simply you will solve this integration and you will get q is equals to 2t plus 3t square by 2 from 0 to 10. So q will be 170 coulomb. Okay. This will be the net charge that will be crossing through a given cross section area. Okay, this was a very basic question. Okay, now the next terminology or the next topic is current density. You have studied about charge density, okay, in electrostatics. Similarly, this is also another type of term, current density. Okay, see, current density at any point inside a conductor is defined as a vector having magnitude, okay, and this is equals to current per unit area. This is current per unit area, okay, and this is what is a vector quantity, okay, means this will be having direction, right? And that area, okay, this current per unit area, this is actually not a complete definition, okay. The complete definition will be current per unit area surrounding that point where area is normal to the direction of charge flow, okay. So suppose uh, the cross section, okay, a current I is flowing, okay. Suppose an area element dA here, which is normal to it, and this will be the direction of what current per unit area, or can say current density, okay. Suppose this direction is unit vector n, and this is area dA, and let's say di current is flowing through it. That this vector j is normal to this can be defined as di upon dA to unit vector n, okay. And if area is not normal to the current, but makes an angle theta with the normal to the direction of current, then you need to take its horizontal component. I'm taking this example. Suppose it is somewhat like this. Area is not perpendicular, okay. Area is pointing towards this direction, okay. You know that this will be direction of vector j, okay, and this is represented by vector j, right? So you need to take the perpendicular area. So perpendicular area will be this one, and this angle is theta. Then area will be dA cos theta. You can say this is a dash, okay. Means you can define j as di upon dA dash, or you can say di upon dA cos theta. This is what the area which is perpendicular to it, okay. So from here you can get di is equals to j dA cos theta, right? And this is what a dot product of j and dA. So this can be written as di is equals to vector j dot vector dA, okay. So you can also write I as integration j. This is a very important result we will be using further in this chapter, okay. Current density j, it is a vector quantity and its direction is same as that of E, right? Now unit of j, what will be unit of j? Unit will be ampere per meter square simply. You can derive this from the formula, and dimension formula it will be L minus, right? So this was basic introduction about the current electricity chapter, okay. We have studied the following terms: electric current, instantaneous current, current density, okay, and we have also solved one basic problem, okay. From the next video we'll be studying about the mechanism of flow of charging metals, okay, where we'll be studying about relaxation time, average thermal velocity, mean, and till then, thank you.